Hi everyone, Morgan here. So we are looking at page 9 of the Thermodynamics outline for AP Chem. And we're going to be doing some products minus reactants questions here. These are possible because enthalpy, entropy, and free energy changes are all state functions. So let's look at our first equation here. Br2 gas plus I minus aqueous. I'm going to need a 2 there. Gives me I2 solid and 2Br minus aqueous. Now, you're going to need access to some standard thermotables, okay? They're in the back of all, freshman chemistry textbooks. It's not a problem to find that. Delta H naught equals. So I need the value for I2 solid. Well, the value for I2 solid is 0 plus 2 times the value for Br minus, which is negative 120.9, minus the value for Br2 gas, which is 30.91, plus 2 times the value for I minus, which is negative 55.94. And all of that is measured in kilojoules per mole. And when I go through and I run that in my calculator, I get negative 160.83 kilojoules per mole. And typically, when I do one of these, I'm going to end up rounding off to a whole number on the AP exam these days. They pretty often like to keep those as whole numbers. Okay, now to find the delta S naught, I'm going to follow the same pattern. Okay, so the value of delta S naught for I2, okay, is going to be 116.14 plus 2 times the value for Br minus is going to be 80.71. Remember, you're not going to see any negative numbers here because these are absolute entropies. Times the value for Br2, which is going to be 245.38, plus 2 times the value for I minus, which is going to be 109.4. And those are going to be joules per mole, okay? And when I go through and run that in my calculator, I get negative 186.62 joules per mole K. And a negative number is all right because that is an entropy change. Delta G naught, finally, we'll take the same approach. The value I2 solid is 0. Plus 2 times the value for Br minus, which is going to be negative 102.82, minus the value for Br2 gas, which is 3.13, minus 2 times the value for I minus, which is going to be negative 51.67, and all of those are kilojoules per mole. And once that has gone through my calculator, that's negative 105.43 kilojoules per mole. And since these are standard thermodata, we know they're all measured at 25 degrees Celsius. Now I want to check if I did this correctly. And I can check it based on that number because I know that delta G naught equals delta H naught minus T delta S naught. So I'm going to plug that into my calculator here. Let's take my value first for delta H naught, which was negative 160.38 minus, I'll do parentheses, 298, that's 25 degrees Celsius, times negative. Now, rather than putting in the negative 186.62, I'm going to put it as 0.18662. So I've converted from joules to kilojoules. Hit enter, and I'm getting negative 104.76. So actually, if I round off to a whole number, I'm getting the same thing, negative 105 for both of them. Cool, that works, that's good. I'm happy with that. All right. Let's go on now. We'll look at number 2. To balance it, I'm going to need a 2 there, and I'm going to need a 2 there. Delta H naught equals, now my value for CO2, negative 393.5 plus 2 times my value for H2O gas, which is negative 241.8, minus value for CH4 gas is negative 74.87, plus 2 times the value for O2. Well, in this case, hey, natural state, that O2 is a 0. And when I do that, I end up with negative 802.35. And that's kilojoules per mole. That's a very exothermic reaction, so that does not surprise me. Delta S naught equals, now my value for CO2, that's 213.7 plus 2 times my value for O2, which is going to be 205.0. I'm sorry, that should have been for H2O, so let me correct that. That should be 188.72. Minus now my value for CH4, which is 186.1 minus 2 times, and that'll be the 205.0 for oxygen. And that is going to be equal to negative 4.96 joules per mole K. Delta G naught equals, now my value for CO2 is negative 394.4 plus 2 times my value for H2O is going to be negative 228.6 minus my value for CH4 is negative 50.81 plus 2 times, and well, for oxygen that's going to be 0. Okay, run that through my calculator, I get negative 800.8. And that's kilojoules per mole. So, let's check it. Delta G naught equals, and I'm going to run all of that through my calculator using the Gibbs equation, negative 802.35 minus parentheses 298 times, and I'm going to divide this by 1,000, so negative 0.00496, close the parentheses, and I'm getting negative 800, so I'm happy with that. That is checking out. Okay. All right. So hopefully you can go on and try the next 2 of these. All right, I hope you're back now. You've tried those. Let's take a look. Delta H naught equals, I need a 2 there. So for N2O4, I get 9.16 minus 2 times, and I get 33.2 out of the tables. And when I do that, I have negative 57.24, and that's kilojoules per mole. Delta S naught, okay, I have 304.3 minus 2 times, and then I have 239.9 equals and I get negative 175.5, but that is joules per mole K. Delta G naught equals, and then I have 97.7 for the N2O4 minus 2 times, and it's 51 for the NO2, and that equals negative 4.3 kilojoules per mole. Okay, I'm going to plug that into my calculator and see how I did. Negative 57.24 minus parentheses 298 times negative. Remember, I have to divide this by 1,000. So that's negative 0.1755. Boom. I'm getting negative 4.94. Okay, close enough. That approximation is working. Okay. So if you haven't tried number 4, go try number 4. Okay, I'm assuming you tried number 4. We balance it with a 2 there and a 2 there. Delta H naught equals. Now, a lot of values there. For the zinc, that's a 0. Zinc 2, I'm sorry, that would be zinc 2 plus ion. My boo-boo there. So for the zinc 2 plus ion, that's negative 152.4. Plus the value for H2. Oh, that will be 0, actually. Plus 2 times the value for chloride ion, which is negative 167.46. Minus the reactants. That zinc will be 0 because that's its natural state. Plus 2 times the value for HCl, which is negative 167.46. Now, you might think I've copied something down wrong, but actually the value here and here would be the same, because remember that H plus is the reference point. Its absolute entropy is 0. That's why those two end up as the same number. All right, so when I run that through my calculator, I get negative 152.4, and those are kilojoules per mole. Delta S naught, okay. So zinc 2 plus, all right. You know, I might have said that was absolute entropy. It's also for the H plus. Works either way on those. All right, so delta S naught. My value for zinc 2 plus is negative 106.5 plus the value for H2, which is 130.6. And you first thought, wait a minute, a negative entropy there? Well, see, it turns out zinc 2 plus has lost electrons from zinc. That's why it ends up being a negative number. Plus 2 times, and then the value for the Cl minus, that's going to be 55.10. Minus, now for plain old zinc, 41.6. Plus 2 times the value for HCl, which is 55.06. Run that through my calculator, I get negative 17.42. But that's joules per mole K. My delta G naught, all right. My value for zinc 2 plus is negative 147.21, plus my value for H2 is 0, plus 2 times my value for Cl minus, which is negative 131.17, get the negative sign, minus the value for zinc is 0, plus 2 times the value for HCl, which is negative 131.67. And when I ran that through my calculator, I got negative 147.21. kilojoules per mole K. So now let's check my delta G naught. I've got a noisy cat here at my feet today. All right, so negative 152.4 minus 298 times negative, I'm going to divide that by 1,000, 0.01742, close parentheses, and I'm getting negative 147, which checks out. That's good. All right, so it's not the hardest thing in the world, but it does take some practice, especially getting used to how to put the numbers in your calculator. Okay, thanks for tuning in. It's Morgan signing off.